In this video, I'm going to discuss the quotient rule for exponents. If you recall, the word quotient means the answer to a division problem. So we're going to be dividing using some exponents. Okay, so the rule says that if we have x to the power of a, and we're going to divide that by x to the power of b, we can write it one of two ways. We can either write it x to the power of a minus b, or we can write it 1 over x to the power of b minus a. Notice that on top it's a minus b, and on bottom it's switched, it's b minus a. Well, so how do we know which one we should use, whether it's this one or this one? Well, we'll get to that in a second. So let's see why this works the way that it does. So using this first example with numbers, we have 2 to the power of 6 divided by 2 to the power of 4. So if I write this out in expanded form, the numerator will have 6 2's. So 2 times 2 times 2 times 2 times 2 times 2. All over, and on the bottom we have just 2 times 2 times 2 times 2. Well, what do you notice about this? Well, I got a lot of 2's. A lot of 2's on top, a lot of 2's on bottom. Well, in fact, since all these are multiplication, I can cancel some of these out. So those 2's will cancel, those 2's will cancel, those 2's will cancel, and those 2's will cancel. So what does it look like that I have left over? Well, I've got 2 2's left over, or 2 squared, or I could go ahead and say that's 4. Well, using the definition for our quotient rule, we knew that if we had x to the a on top and x to the b on bottom, we were going to say a minus b and put that in the numerator. So if we did that, a would be 6, b would be 4, 6 minus 4 is 2, so 2 to the power of 2. And that's exactly what we saw. Well, how do we know if we're going to use the x to the power of a minus b or 1 over x to the power of b minus a? Well, if we look at another example, let's use 3's this time. 3 cubed on top and 3 to the 7th on bottom. Okay, so in expanded form, this will be 3 times 3 times 3 on the top. And the denominator will have 7 3's. 1, 2, 3, 4, 5, 6, 7. Okay, so if I notice, those 3's will cancel, those 3's will cancel, those 3's will cancel, and that all cancels, leaving me with a 1 on top. And then how many do we have down here? We have 1, 2, 3, 4 3's. So I have 1 over 3 to the 4th, or I could say 1 over 81. Well, if you notice here, I had 3 on top for my exponent and 7 on bottom for my exponent. So I could do 3 minus 7, and then I would get negative 4. Or I could say, hey, look, my denominator is bigger, so 7 minus 3 is a positive 4. So in general, whenever you're using the quotient rule, if the exponent on the top is bigger, like it was in the first example, 6 is bigger than 4, I'm going to say 6 minus 4, and I'm going to leave it on top, so my 2 squared was in the numerator, because that 6 was bigger than 4. However, if my denominator's exponent, this 7 right here, is bigger than my numerator's exponent, which was 3, I'm going to say 7 minus 3, and since the denominator is bigger, I'm going to leave it in the denominator. So 7 minus 3 is 4, so 3 to the power of 4 is in the denominator, with a 1 in the numerator, because notice, remember, all this stuff will cancel out and just be left with a 1. So you'll end up with 1 over 81. Now let's look at a few examples that use variables instead of real numbers. So in this first one, if we have x to the power of 5, and we're going to divide that by x cubed, we could look at it the same way that we looked at the last values, or the last examples, and we could say we have 5x's on top and 3x's on bottom. So 3 pairs are going to cancel, and we're going to be left with x times x, or x squared on top. I could also use the rule and say the 5 and the 3 are my exponents, and 5 is bigger than 3, so 5 minus 3 is 2, so my exponent will be 2, and it'll be left in the numerator, since the numerator's exponent was bigger than the denominator's exponent. In the next example, however, I have y to the 10th over y to the 13th. these exponents are much too large. I don't want to write out 10y's on the top and 13y's on the bottom and start canceling stuff. That seems pretty tedious. So instead, I notice that 10 is smaller than 13, which means the denominator's exponent is bigger. So I'm going to say 1 over y to the 13 minus 10 power, and that's going to give me 1 over y cubed. And again, I know that my exponent's going to be on bottom because my denominator was bigger than my numerator's exponent. So the next example is m divided by m squared. So remember, if my variable doesn't have an exponent, it's understood to be 1. So I notice my denominator is bigger than my numerator, so 2 minus 1 will be 1. So my exponent is 1. But if my exponent is just 1, I don't really need to write the exponent. I can just say 1 over m. In this next example, I have k to the power of 4 divided by k to the power of 4. Well, I can look at this one of two ways. Anytime the numerator and the denominator are the same, can't I just cancel them out and say 1? Because 5 divided by 5 is 1. So using that rule, we would just say this is 1. But to be sure to use the quotient rule for exponents, we would say 4 minus 4 is 0, so we'd get k to the power of 0. And as long as k is not 0, we're going to get 1, because anything other than 0 to the power of 0 is 1. Okay, this next example is x to the 9th, y to the 5th, all divided by x to the 4th, y to the 7th. So now we have multiple variables involved, so I'm going to deal with my x's first and then my y's second. So for my x's, I have 9 for an exponent on top, 4 for an exponent on bottom. My 9 is bigger than 4, so I'm going to say 9 minus 4 is x to the power of 5, and that will be left on top, since the 9 was on top and it was bigger. For my y's, I have y to the 5th on top and y to the 7th on bottom. So since my 7 is bigger than 5, I'm going to say 7 minus 5, and I'm going to put that on bottom since that 7 was bigger and it was on bottom. So my final answer for this is x to the 5th over y squared. So one final example is ab cubed divided by a cubed b squared. So this is pretty similar to the last example we did, with the exception of, since this a doesn't have an exponent, we're going to put a 1 right there. So now let's deal with our a's first and our b's second. So a to the first over a cubed, well, 3 is bigger than 1, so we're going to say 3 minus 1, and that's going to go on bottom, a squared. 3 minus 1 is 2. And on top, I have a b cubed and a b squared, so 3 minus 2 is 1, so he's going to go on top, b to the 1. But because we don't like to have this 1 right there, because it's understood that it's going to be 1 if there's no exponent, we're going to write b over a squared, and that's my final answer. I know I said that last example was the final example. However, we haven't looked yet at examples that involve negative exponents when using the quotient rule. So let's look at 2 examples of those and then we'll be done. So this first example has x to the 5th on top and x to the negative 3 on bottom. So using the quotient rule, we're going to say x to the 5th minus a negative 3. Since the 5 is larger than the negative 3, it will be 5 minus this negative 3. When we do that, we'll notice that the minus and negative becomes a plus, so it'll be x to the 5 plus 3, which will be x to the 8th. Notice, however, we could solve this same problem doing it a different way by first fixing this negative exponent, and since he's negative on bottom, we can slide him up top, and it'd be x to the 5th times x to the 3rd, which then we could use our product rule and say 5 plus 3 equals x to the 8th. So you'll notice in both cases you're going to get the same answer. Okay, so now for our final example, we'll do m to the 4th n to the negative 1 all over m to the negative 3 n. Okay, so again using our quotient rule, we can look at the m's first, and we would say 4 minus a negative 3. So 4 minus a negative 3. And we put it on top, again, because this 4 is bigger than the negative 3. And on bottom, we would deal with these n's, because this is really n to the 1, and 1 is bigger than negative 1. So we would say 1 minus a negative 1. So in both cases, we're subtracting a negative, so we can kind of fix these and make them both pluses or addition problems. 4 plus 3 is 7. 1 plus 1 is 2. So our final answer on this final problem would be m to the 7th over n squared.